Okay, we are going to do some free response problems now. And we're going to start with rates and straight line motion problems. So I'm just going to go through year to year. This is where you find the problems that are going to help you uh, year to year on this type of question. Okay, so 19, 18, 17, 15, and 13. 2019, number one. Now, first things first with free response. Number one and number two, they're going to be the calculator questions. This is number one, the rate question. Fish enter a lake at a rate modeled by E. This is a rate. This is a derivative. This is a velocity in. Fish leave the lake at a rate modeled by L. This is a velocity out. It's a derivative. E and L are measured in fish per hour. The two big equations that come into play with rate problems are like a total amount of fish will equal an initial amount plus a total in. So area under derivatives equal changes in totals. So integral of E is total in, and then integral of L would be the total out. Now, if I take the derivative of this, we get T prime. T prime is just E minus L. This is the rate of change of the total. This is like how quickly fish would be coming in or out. So E being a derivative, L being a derivative, subtract the two, and that's like the velocity of my total. That's how we're going to find maxes and mins and stuff like that. How many fish enter the lake? So this is just going to be an integral of E. This is just the total in. So in a calculator, I'm showing you your calculator for these questions. Math 9, 0 to 5, 20 plus. Make sure your calculator's in radian mode. And we get 153. Round your answer to the nearest whole number, 153. Now for your for your response test, you got to show this. Never write math 9. Literally, you would write this down, and that's all you need to do, guys. This will give you full credit if you write this down. Okay? Don't just provide the answer. Write this entire thing down. It's the average number of fish that leave the lake per hour. Okay, that's an average L. Okay, this is rate at which fish are leaving in fish per hour. The average L, average number of fish, is what we're trying to find. We will do our friend, the average formula, 1 over b minus a, integral from a to b, of what we're trying to find the average of. Okay, this comes from the rate of change of, I guess, the total fish that have left. It doesn't matter. That's the formula for average. Let's just stick with that. This is all you have to write. Shows you know what you're doing, and then you get the answer from your calculator. They don't ask it for a whole number, so you're going to provide the decimal rounded or truncated to the third decimal place. .059 fish per hour. They don't ask for units, so probably best if they don't ask you. They're kind of providing the units here. Like, don't provide units unless they ask you, or else you might make a mistake. So this is fish per hour. This is average. All right, here we go. When do we have the greatest number of fish in the lake? Okay, when is the total a max? We want to find the max. T. Well, that's when T prime is going to change signs from positive to negative. We need to look at the graph of T prime. T prime, which is the derivative of the total, is E minus L, velocity in minus velocity out. We don't look at the derivative of E, the derivative of L. No. These are derivatives. 20 plus 15 sine pi t over 6. You can look at these separately if you want to. See like rate in minus rate out, and you should be able to figure it out, but I prefer to look at them together. Just make sure you're subtracting the entire L. I'm also going to graph 0. We're looking from the window of 0 to 5. A little concerning. 20 plus 15 rating mode. Make sure you're ready. 20 plus 15 sine pi t over 6 minus 4 plus 2 to the 0.1 t squared. What am I missing here? Is t prime just positive the entire time? All these y values are positive. We're up here at 29, 28, 27, 26, 25, 24, 23, 22. Like, probably the first thing you were probably thinking is like, hey, guys, oh, 0 to 8. Yeah, whenever you like don't see a max or don't see a 0, you're looking for a 0 of a derivative, right? You should be a little bit suspicious, but that's fine. Just double check things. This is me double checking. I saw the values get down. Okay, boom. All right. So t prime is positive, then negative. That means the total amount of fish is going up then down. The max must be here. Now, you need to be able to say what I just said to get proper justification points. Okay? You can say, and you can't just say, oh, it just changed from positive to negative. Okay, you could say, since from 0 to, and let's find this value. Second calc intersect, because I graph y equals 0. Since 6.203, since t prime, which is e minus L, is positive from 0 to 6.203, okay? And you got to put this interval down because it shows you're talking about the entire interval, 0 to 6, 6 to 8, and t prime is negative from 6.203 to 8. T equals 6.203 is time of max fish. Boom. You don't have to find the amount of fish, you just find when. And you got to justify. This is easy. You don't have any candidates. If you were to have candidates, you would have to find values and compare them. Okay? Part D, is the rate of change in the number of fish in the lake increasing or decreasing? Now, this is tricky. Okay? Is the rate of change increasing or decreasing? The rate of change of the total amount of fish is E minus L. Now, you could look at E minus L at 5 and say, like, the slopes are negative. The slopes look negative. Okay? Like, we have graphed E minus L. And it's like, how is this changing? Is it increasing or decreasing? And you can kind of see what's going on at 5. At 5, your values are definitely decreasing. Okay, now you can see that, but this is not proper calculus justification. Okay, proper calculus justification is to look at a slope, a sign of a derivative. Second calc, find your derivative of E minus L at 5, and you say, okay, the derivative, e prime minus L prime, is negative. That means the rate of change is decreasing. Okay, the rate of change is E minus L. Is that increasing or decreasing? You can see it's going down. It's decreasing. Okay, now you could say like the slope of E minus L is negative. Don't ever say I looked at the graph. You can also say the rate at which it's decreasing, T double prime at 5 is negative 10 point whatever, negative 10.722. All right, let's look at how points were distributed. I don't know if I actually have the scoring guidelines. I think I just have my answers. Yeah. Second derivative, negative 10.7. Okay, let's look at the scoring guidelines. It's very easy. AP Calculus 2019 scoring guidelines. Usually it pops up right away. All right. 2 points. One for 153, one for having an integral. Part B, 2 points. One for 6.059 and one for the integral. Okay. Part C, 3 points. Setting E minus L equal to 0, finding your answer 6.2035, and then having your justification. Now, this is my justification. What they did is the candidates test. They were like, oh, let's find the total amount at this value and then look at our endpoints as well. I just said, like, listen, it has to be the max. E minus L is positive on this interval. E minus L is negative on this interval. I have to talk about the entire interval, or else I know that's not going to be any other candidates. And I don't even have to even compare any values. And then look, E prime minus L prime, negative 10. Considers E prime, considers slopes. Those are 2 points, okay? So there you go. There's your first one. Next problem we got to do is 2018 number 1. 2018 number 1, another calculator question. We got people entering a line for an escalator at this rate, and then people exit at a constant rate. This is a rate. Consider this. I don't know, another function. Okay, but you don't put 0.7 t. That would be like the antiderivative, and that would give you the total amount that have left. And look at that. There are 20 people in line at time t equals 0. So this is our initial amount. How many people enter the line? Okay, enter the line, total in. This is the rate at which they're entering. This is the velocity at which they're entering. Take a area under a velocity to get a displacement. Take an area under a derivative to get a change in a total. We're going to plug in this fun equation. Math 9, 0 to 300. Got to type it in correctly though, guys. 44 t over 100 cubed times 1 minus t over 300 to the 7th. $270. Okay, that's how many people have entered. During the time from 0 to 300, there are always people in line for the escalator. How many people are in the line at time t equals 300? So people are getting on the escalator at this. They enter the line. How many people are in the line? What is our total amount at 300? Well, This is just like the last problem. I have my initial amount. I have the total that have entered. That should be R of t. This is what you're writing down, and then minus the total I have left. Now, the total I have left is 0.7 people per second over 300 seconds. You could do zero point 0.7 times 300. You literally could do that. Or you're just like, let's just stay with what I know. 0 to 300 of the rate out. The rate out is 0.7. Okay? So we got 20 people plus this many people that have entered minus 0.7 times 300. $80. No, 0.7 times 300 is 210. So put them all together. What do you get? 80. There's 80 people in the line at 300. For t is greater than 300, what is the first time that there are no people in the line for the escalator? Well, I start with 80 people. I'm not going to have anybody wait in line anymore. There's no more people after 300. I'm just going to lose people at a rate of 0.7 per hour. Now, this is how many hours it would take to get to 70, to get 80 people like out of the line, because the rate is 0.7. You could also said like, oh, I have 80 equals the rate out from 300 to k of 0.7. This would be how you could find like the exact value k. I don't know. This is not like, I don't want to trick people up. I think people would naturally do this 0.7 per second. How many seconds does it get? 80 is 114.285. But at what time t? It's not at 114.285. It's 114.285 plus 300. So 114.285 plus the 300. Let's see, I got that 80 divided by the 0.7. It'll take me that many seconds and then plus 300. So 414.285. Let me show you the other way. It's like, okay, from the 300 second to some time t, if we're losing at 0.7, how long will it take for us to get 80? Get rid of 80 people in the line. We would like take the antiderivative, plug in 300, plug in k. 80 equals 0.7 k minus 0.7 times 300. And then you do like 80 minus 0.7 times 300. Divided by 0.7. Whoa. Wait, what did I do here? I made a mistake. Oh my gosh. Mr. Messner! Add. Silly, I'm not even thinking. Add. Then divide. I'm going to get that exact number, 414.285. Boom! Okay. So there's the other way to do that same question. D, from 0 to 300, what time is the number of people in line of minimum? This is like when I'm my furthest right, when I'm my furthest left, you look at the derivative, okay? You look at the derivative, signs of the derivative, when they change. Always look at derivatives to find maxes and mins. So t prime being the total's derivative is r minus 0.7. I'm going to see when that equals 0. I'm going to graph again. And I need to find the number of people in line at that moment. So here we go. Y equals, my friend, 44 times t over 100 cubed times 1 minus t over 300 to the 7th. Don't forget minus 0.7. Fun. From 0 to 300. Unfortunately, I'm going to change my X scale so you don't see. Yeah, there you go. Every one of these is 10. Isn't that nice? Unfortunately, we have candidates. Okay. So where are you going to have a possible min? You have a min here. T prime is negative. Then positive. Then negative. Okay. Possible min locations must be here or here. Now, why can't it be here? Because this is a relative max. The justification for this is tough. A lot of times, like sometimes it's actually easier to just like find a bunch of values and be like, here are my candidates. The endpoints here and here, n1 t prime equals 0, which are here and here. I don't like to like do that. Like if you can write up the proper justification, I think it's quicker because like man, it's like just annoying. I know this isn't going to be the min because t prime is positive and negative. So here's what I always say. You're like, okay, T is a min. T is a min. Total at an endpoint or when T prime changes sign from negative to positive. I believe they accept this. I don't think they want to accept that, but they like it. Okay. Now, you have to exclude T of 0 is not the min because T prime is negative from 0 to this intersection. $33.013. So you could even write the candidates here, 33.013 and then 300. Okay? And you say T of 0 is not the min because T prime is negative from 0 to 33.013. But like is that necessary when you know there's 20 people in line at T equals 0? I mean, I don't know. Like usually what they like to do is like, okay, here are my candidates. Then you do this like, okay, T of 0 is this, T of 33.013 is this. They probably even include the other one, which I know is not going to be the min. And then T of 300, which is a possibility. You know it's not that. We know what this is. This is 80. So we're just got to find this. And we have to compare it to the other ones. I know this one's going to win. I know for a fact that this is going to win because, um, 20, I'm going to decrease to get to here. And then I end up at a larger value because it's going to be larger than 20. 80 is larger than 20. So I don't know. Let's find the value. Did it up here, right? There you go. This. Grab that. Oh, bummer. Wait. I need that too. That's the most important part. Oh, I'm making this more complicated, but this is how many people I leave. I'm using X because I had the intersection. I don't believe you have to show this. And I'm adding how much we're getting in. I'm using X because when you find the intersection, you use X, and X is the intersection. So I'm adding that, but at that 33 number, making sure again you're using that entire decimal, and I get oh shoot, okay, 20 minus that plus that is the same as like the initial plus total in minus 20 total out. Just initial minus total out plus total. Yeah, 3.803. I knew this has to be the winner. And I probably could have said like right off the bat, you just like, I know T of 300 is bigger than T of 0. I know T of 0 is not the min. Boom. You could say like T of 300 is 80, which is greater than T of 0. Therefore, the min is T of 33.013 at 3.803. Everybody hates writing like the justifications, okay? But it doesn't take that long and it's not that hard. You can reference the candidates test or just talk about signs and derivatives. Let's go to the scoring guidelines for this one. Maybe I can. Uh-oh. We're working too hard here.